In this problem, we want to find dy dx using the quotient rule, okay, because this is a fraction. So we're just going to start with that and then see where this problem takes us. So using the quotient rule, the derivative dy dx is equal to, if you use the little memory device, it would be low d high minus high d low over low. That is the denominator, x minus 1, times the derivative of the numerator. So I'm just going to write times the derivative of x squared plus 2 all cubed, and I'll find that derivative in the next step. That's low d high minus high, that's just the numerator. D low is derivative of the denominator. That derivative is pretty simple. The derivative of x is 1 and the derivative of 1 is 0. So there's my low d high minus high d low over low, the denominator squared. Now we need to find the derivative of the numerator right here. This derivative is a little bit complex, and that's because you've got an inside function and an outer function that cube. Now one way to do it would be to use the product rule. That would be probably the hardest way. Grouping two factors together and then leaving the third as the second factor for your product rule. You could also more easily FOIL all of this out since it's being cubed and then find the derivative using the power rule. But let's practice finding that derivative using the chain rule, okay, for that. Where the inside function is the x squared plus 2 and the outside function is the cube. So for its derivative, we're going to bring this 3 down out front. Okay, and I'm going to do this as I fill it into the whole big picture here. So I'm going to go ahead and write my denominator, and I'll write this first factor, x minus 1. Okay, now I'm going to find that derivative. So chain rule says you differentiate the outside function around the inside function, so we'll bring the 3 down, times the x squared plus 2 to the power of 2. We reduce the power by 1 by the power rule. Then times the derivative of this inside function is 2x plus 0. Okay, minus parentheses x squared plus 2 all cubed. Now you may be able to enter your answer like that. This is not a simplified answer, so you just have to try it and see if it accepted it is correct. I'm not entirely sure. I would personally probably simplify first, partly just for the practice of simplifying. Okay, so let's see, in my first big factor right here, I've got this 2 and this 3. All right, let's highlight those, that 2 and that 3. And the x, I'm going to go ahead and pull out to the front just to simplify it as 6x. Then I've got this x minus 1 to the first power, and an x squared plus 2 all squared. Minus an x squared plus 2 all cubed all over x minus 1 all squared. That's probably not a bad way to enter it, really. But I say that because we have 3 terms. This is our first big term, this is our second big term, and then the denominator is a term by itself. None of these 3 terms have any common factors, so it's not like we can just factor something out and cancel common factors. That wouldn't work because there's no x minus 1's here, and then in the denominator there's no x squared plus 2's all squared. Yeah, you could factor out an x squared plus 2 squared from the numerator because this first term has 2 of them and the second term has 3 of them, so we definitely could do that. If we take out 2 of those x squared plus 2's, then in my numerator I'd be left with this 6x times x minus 1 and minus, I took 2 of them out, but there were 3 in this term to begin with, so I still have one more factor of x squared plus 2 in that second term. So you definitely could do this. Then you could clean up what's inside the brackets because that wouldn't really take that much work to do, and it's possible you might end up with something else that simplifies here, although I kind of doubt it. But let's see. if we distribute this 6x over the x minus 1, we'll have 6x squared minus 6x. And if we distribute that negative, we'll have minus x squared minus 2. There we go. Okay, then combining like terms inside of that set of brackets, we have, and I'm going to just write it as a parenthesis instead of a bracket since that's not really necessary here at this point. 6x squared minus 1x squared is 5x squared minus 6x minus 2. Okay, and this is probably a good stopping point. The only thing we could really do here is check to see if this factors, the 5x squared minus 6x minus 2. The only factor we're really interested in it potentially even having is x minus 1, which is possible, so let's just try it real quick and see. I'm going to try to factor this quadratic right here, the 5x squared minus 6x minus 2. So the first two terms have to multiply to 5x squared, so the first term here's got to be a 5x, and that term's got to be a plain x. Then the last two terms have to multiply to negative 2, so one of them's got to have a 2, and one's got to have a 1. And we want the middle terms to add to negative 6x. I don't see a way that this is going to happen right here because the way I've set this one up, the outside term is negative 5x, and my inside term is positive 2x, which adds to negative 3x, so that doesn't work. If you switch the signs and make it minus plus, that's still not going to work because you'd have 3x, or 5x minus 2x is positive 3x. So the other thing you could do is switch the location of the 2 and the 1. Let's see, that gives us, it doesn't change anything, does it? Is that right? Or did I multiply that wrong a second ago? Let's see. If we do it this way, you have 5x minus 2x, that's 3x. Let's go back. Let's make that a 1 and that a 2. Let's do 1 and 2. No, it's still not going to work because you'll have 10x and 1x, which add to 9x. You'll never get a 6x. So this is a fully factored solution. You could expand it all out, but I think this is probably considered a little bit more simple to write than expanding it all out.